you can know a function is a function just by looking at its graph, because you can use the vertical line test. If the vertical line crosses the graph twice, then you know it has two solutions for the one input. You can only have one solution or one output for every input if it's going to be a function. Okay. So my other question to you guys is this. Now this is more for application problems, like word problems and such. What do these numbers mean? Up here on my screen right here, there's a bunch of numbers. You have numbers inside of the function right here, and you have numbers on right there and right there. What do they mean? Talk to your partner or neighbor about it. Okay, so if I had this point right here, what are my coordinates here? That's what would you say? Is that 17 or 17.5 maybe? And then what's the y? 20. Okay, so what does this 17 mean? No, yeah, it's the x. What does it mean in this problem?
Years.
Yeah, x is your years, and this is paid vacation days. Okay, so that's how you would, yeah, just reading a graph right now. Okay, now this is where you probably got to start writing some stuff down here. Write these two equations down. We're going to determine if these represent a function. Now, my question right here isn't specific enough. Normally, it should say something like, determine if the following represents a function of x, okay, or of y, whatever. Most of the time, it says of x because we like to see x with all the numbers, and we like to see y all by himself. It's just what we're used to seeing. So, if we wanted to see if this is a function of x, we got to get the y alone. So we get the y alone by subtracting x squared from both sides. So we have this. And then we ask ourselves, is that a function? Yeah? If you plug in any x number right here, will you get exactly only one x? Or, I'm sorry, one output, one y?
Yes.
No, I mean like for each x value. Like if I plug in a 2, I'm only going to get one y value, right?
Yeah.
If I plug in a -2, I'm only going to get one y value.
Yeah.
Yeah. Now, 2 and -2 might give you the same y values, but that doesn't mean it's not a function. It just depends if each x value has exactly one output. Let's check out this other one. If I solve for y on this one right here, that would be, let's see, y squared would equal -x squared plus 4. And then how would I get that y alone? I would square root both sides, and so I get y equals the square root of -x squared plus 4. Now there's something wrong with what I just wrote.
X doesn't go in there. 4 doesn't go in there.
The 4 doesn't go in there? Well, you have to square root the whole side. So yes, the 4 does go in there, but there's something else. Plus or minus. Whenever you're inside of an equation and you take the square root, you must have a plus or minus on there. Now, think about this one. If I plug in something into x, will you get 2 y values?
Yes.
Or I should say, would you get more than one? And the answer is yes. You would get a positive value and a negative, right? Right. Okay. Now, before we graph this, let's write this in function notation. To write in function notation, you're just giving it a name. In this case, we're going to call this the f function. And right here, you write down what you actually plug into the function. And so we have x representing the place where you plug in the number. So if I plugged in f of -2, I will put a -2 in for every time I see an x. So as you can see right here, I just put the -2 in for x, and so over here, I put the -2 in for x. Everything else stays the same. You still have that negative there, the square, and the plus 4. So let's graph it. Now what's the most basic way to graph a function? Do you guys know? Plug in points. Create a table. Alright, so I'm going to say x, and we're going to call this f of x. We'll keep it with function notation. You could use a y, but I like getting used to using f of x right here. Okay, so if I plugged in the -2, let's also plug in a -1, a 0, 1, and a positive 2. If I plug in a -2, what do we get right here? So that would be 4, and a negative would be on it, plus 4. That is 0. So technically, you can say it like this. If you plug a -2 into this function, you get 0, which would give us our point. Our point is 2, 0. The 2 is your input, and 0 is your output. Which one's the domain, the input or the output? The input is your domain. So we got a lot of vocabulary going on right here. That's why I wrote all this stuff right here. I just want to make sure I hit every single one of these words. Okay, so if I plug in a -1, let's do this part in our head. If I plug in a -1, what do we get? -1 squared is +1. We put a negative on it, add the 4, we get 3. And if I plug in a 0, ooh, I love putting zeros in. 0. 0 squared is 0. Can't have a -0, so it's just 0. 0 plus 4 is 4. And then we have a 3 and a 0. So if you plug in all these, you'll get those numbers. I only plugged in 1 and showed my work for one of them, but let's just do this for the sake of time. So if I graph this, this will be -1 and -2. I plug in -2, I get 0. I plug in -1, I got 3. So I go up to there. Plug in 0, I get that, and that. Okay, so those are all my points. So we can look at the graph and say, yes, that is definitely a function. I can see the trend. This line's going to continue to go that way, and this line's going to continue to go that way, and they'll never cross each other. Therefore, it'll always pass the vertical line test. Okay, what is the domain for this function? Now, for the domain, which axis do we look at? Do we look at this one right here, or do we look at this one right here? Which axis? The x-axis, right? And so, when we're asked the question, what is the domain, we have to look at see how many of these x's could actually be in our table right here. And the answer is all real numbers. So, how do you write that in interval notation? It would look like this. I'm going to say D is -infinity to +infinity. And make sure you guys put parentheses around the infinities because they are not numbers, they are concepts. You can't include them in our interval. Now what about our range? Now our range is when things change a little bit. Okay, now remember, for range, even for domain, you always have to go from the bottom up or from left to right. From smallest number to biggest number. So we're going to start down here and work our way up. And so actually we stop right here. And we continue down there. You see these arrows, how they're going downwards? That means we have to put -infinity for our smallest because we don't have the smallest range number there. So I put -infinity right there, and then what's my biggest range number that I can have? 4. And we have to include that dude right there. All right, so we got our domain, our range. Do we have any intercepts here? Yeah, okay, let's see. Our x-intercepts. What are our x-intercepts? Yeah, -2, 0. +2, 0. And, oh yeah, you can say plus or -2. That would be a shorter way to write it. Do we have any y-intercepts?
0, 4.
Okay, so I'm going to write y-intercept. That is 0, 4. Very good, very good. Now if it said intercepts, you could just write the points there, but all right, that's all of it. Now this says evaluate it. Whenever you're asked to evaluate, that's when you plug in a number to the function to figure out what it is. Just by looking at this graph, could you guys tell me what f of 1 is?
Yes.
Look, there's 1 right here. If it says, what is f of 1? You would go to 1 and look up. Where's that point at? What is this number right here?
3.
3. So the f of 1 equals 3. All right, that's all the stuff you guys are going to see today.
Yeah.
Now for our green function, it would look like this. Oh, actually, we can't name it f. We can name it g because we already used f right now. So this is our g function, plus or minus. Well, actually, we know it's not a function because of this. If I plugged in a -2, I plug a -2 in for this x right here, square it, there's a negative, plus 4. Okay, if I plug in -2, I want to get 2 outputs. So we're going to have plus or minus, and this is going to be a 4, and it's negative. Actually, this is a bad example because for -4 plus 4 is going to be 0, and x actually just one solution. So at -2, we only have one output. But let's try another one. Let's try a -1. If I plugged in -1, that would be -1 squared. Make that a negative. And we have to add 4 to it. There we go. We can move that up there. And then we have, that's -1. And so that's going to be -1 plus 4, so we have 3. So we have plus or minus the square root of 3, a positive rad 3, and then a negative rad 3. So that gives us two solutions, or two outputs for one input, two range numbers for one domain number. So this one is clearly not a function. Now if we were to graph this g function, I cleared everything and gave ourselves a little graph, and there's my table. If I plugged in -2, remember we got a 0. Yeah, we plugged in -2, we got 0. So if I plug in -2, I get 0. And actually, if we plug in +2, we would also get 0. Because the x is squared, it doesn't matter if it's negative or positive, you'll get the same result. So for -2, we got 0, +2, we got 0, and when we plugged in -1, we got positive and negative radical 3. So positive and negative radical 3 would go right here and right here. And that would approximately be positive and negative 1.7, and the same for this one, positive and negative 1.7. And actually, if we plug in a 0 into our g function, we will get positive and -2. So if we go to graph this, at -2 we would be at 0, +2 would be at 0. At 1 we'll be at 175, which is about right there. Let's see. And then -1 will be at 175. And actually at +1, let me put the other point there. It's also right there. So it has 2 points at +1. And then at -1, it's at positive 1.7 and negative 1.7. At 0, we're at 2 and -2. So when we finish graphing it, it's supposed to be a circle. It looks kind of not like a circle, but that's what it would look like. Now for the domain, I just want to do the domain and the range for this really quick. I think the intercepts are kind of obvious. This will be our domain because this is everywhere where we see the function. So we only have to worry about from here to here, and it is included. So our domain for this function goes from -2 to +2, and it's included. For the range, it's just the opposite way, but still it's -2 and +2. Not opposite way, but it's up and down instead of left and right. So we have -2 to +2. And that's domain and range for a function that looks like this. It's kind of neat. I like it. Hope it helps.